We are now going to have a panel discussion on future directions for NLP at industrial scale. Joining for the panel discussion, we have Dr. Sandeepan, Dr. Shirish, Dr. Manish Gupta, and Dr. Niyati Chaya, and it will be moderated by Dr. Vasudev Verma. Sir, over to you.
Thank you. Neeti had a medical emergency, so we requested Srinivas Bangalore with a very short notice to join the panel today because he represents both the worlds. So Srinivas, please join. And I also request other panelists, Sandeepan, Manish, Sirish. I'm not watching. All right. So Professor Sangal set a very high bar for panel discussions in the morning session. It's very hard to meet that benchmark. But then, the topic that we are going to discuss today is something that is in everybody's mind. It's in the, it's the elephant in the room. So, of course, there is some background that can be set. I'll try to do that in a minute or two. But then later, we will sort of layer our discussion into three aspects, and I'll come to that again. So one is, of course, there is LLMs came in, the foundation models are like one a day or maybe more. And with all these things, like, you are able to do amazing things with even like few shot or is sometimes zero shot kind of a learning, and then make them incredibly versatile. However, if you push the limits of these systems, it is clear that in one sense, we are only scratching the surface of it. We really do not know what is really happening. That said, most of this understanding that we have as a learners of LLMs or the users of LLMs, and then but when it when the rubber meets the road, when the industry applications are being built at the industry scale, there are significant technical challenges. I think we all are aware. I mean, you are very aware of that. So we are here to learn those things. Right. So, I mean, can be many, many aspects. Of course, in the morning, somebody talked about the cost being a very important element here, while the latency also poses some significant bottlenecks for the real-time applications. Again, I think, Srinivas, we had a discussion on that yesterday. And the other questions on the interpretability, and there's so many other challenges of this kind that we are facing today. Right. And at the same time, as we are looking at the current landscape that offers us unparalleled opportunities, like the rise of multimodal models that we are looking at. And then also, many of us have been very passionately discussing about low resource languages as being another exciting frontier. And then we've also been talking about domain-specific applications, adoptions of these aspects, and so on. So this is basically what the point that I'm trying to make is there are unbounded, unparalleled, unimaginable opportunities that are available with this, right? So, but then I think if the discussion is all about being amused and drowned in the excitement of what the magic that we have been experiencing, and also maybe have some discussions on the limitations, but at the same time, instead of being completely submerged in this hype, can we also think beyond LLMs and the transformers and then all those, the new recent buzz, and then also talk about, is there any NLP left beyond LLMs and Gen AI models that is actually useful for the industry? So these are the important elements I thought we should discuss today with, so having said this, right, having said this part, like I wanted to also mention basically the layered approaches that I think we should talk about. One is the demystifying the whole thing. What is the myth versus the reality in adoption and then interpretation, understanding of this particular area, the hype from the practical challenges and also the successes that we have seen today in deep tech and the context that we have seen. And then the second part would be about from all your experiences, what is the real value addition by these technologies in helping customers, adding value to the customers, and what are really these cornerstones of success? Okay, that is the second thing that I think we should discuss a little deeply. And then more than that, the third part, as I mentioned earlier, NLP beyond and other than this LLMs and Gen AI. With that particular, in this context, maybe I'll request Sirish, you've been sort of in the middle of a lot of action, a lot of disruption in the last few years that I know. So what are your thoughts?
Can you hear me?
Yes.
Yeah. So firstly, let me acknowledge that it's an amazing tool. There are a lot of things that we are seeing possible, which were sort of simply not possible before.
Sirish, I actually forgot my duty of introducing each one of you. Can you
Okay,
start
should I
a
introduce
brief
myself?
introduction of that?
Okay, I'll keep it brief. I've been with TCS Research for about 15 years. My PhD training was more information theory than NLP. Last 10 years, I've been working in various topics in deep learning with problems in NMT and stuff like that. The first problem in language was actually crowdsourcing for speech transcription and all. And last 3 years, I think as LLMs came, I think working in natural language has meant working on everything, right? From code, tools, images. So it just blew up. Okay. So, I mean, should I answer and then? Okay. So, before I go to the negatives, let me talk about positives. We had two amazing experiments which worked out very beautifully. We were trying to use agents to sort of do some sort of, the entire marketing ops, like build a media, build a video, put it on the web and play around. And we built on top of this Autogen platform that had come. It works out fantastically. And in another case, we have teams which work in AI for science, and they spend a lot of time reading papers, building code. And we thought, can we kind of, numerical software building, can we do this very fast? In both cases, the early promise was great. But then what happens, you see that, you are kind of you have this Tom and Jerry sort of cartoons that you plug one hole, then some hole comes from somewhere else, and you're plugging another hole. So you quickly realize that you actually need a far more complex system with verifiers. Then the verifier is LLM based. Is it really grounded? All these issues start coming up. And one thing you sort of realize is that somewhere you will continue to need to have a human in the loop. You cannot, we are nowhere close to having this sort of a fully autonomous sort of system. There are the reporting of a lot of these LLMs on academic benchmarks when you take on very complex systems. I don't know how much of it always holds. Okay. And the other thing is that sometimes some claims, I think, like, for example, it becomes very fashionable. For example, I think I mentioned this when we spoke that, look, I would love to simulate role play, and this will allow me to, let's say, get rid of A/B testing. And it looks fantastic, right? But it's ungrounded. So, like I say, behave like someone from this region, like a 17-year-old. It will have some surface level artifacts, but then you really want to use it in production, you realize that no, it's an issue. Diversity is an issue. So when you really start deploying, you start seeing many challenges and works to be done.
So, Srinivas, I'll actually surprise you now. Sirish mentioned about the human in the loop. And then yesterday, I think the most important message that you want us to take home was also the same concept. So do you kind of agree or?
Actually, frankly, I was very surprised by your answer because I thought I was going to be the outlier here. Yes, Sriram touched on something, in his experimentation that eventually seems to have discovered the need for semantics, the need for control flow, which is what NLP dialogue management is all about. And we build enterprise class customer care, and we build it for large enterprises like Nike, Western Union, and so forth. And they are very brand conscious. They don't want to expose their customers to the vagaries of LLM, right? Just like you don't want hallucinations in your code base. The only answer is human in the loop. Now, the challenge is non-trivial because especially in our cases where latency is a critical issue. In Sriram's case, latency may not be that much of a problem. But when you put humans in the loop and the latency is high, then the impact on user experience is significant. You don't want dialogue systems where you're asking about your order not being shipped in the right place or something, and you have to wait for 5 minutes for the next prompt to play. That impacts user experience. So while the conventional wisdom to manage the hallucination problem is to have human in the loop, it's not clear, at least to me, as to how we do that at the latency requirements of a real-time system. Right? We've done human in the loop for analysis, for understanding. And when you put that into the loop, it's like 2 seconds of latency. And even that is perceived by the user that somehow the system is not coming back in time. If we were to automate it and get the semantics correct the first time with automation, it's much more snappier, right? So when you talk about generation and we have human in the loop for generation, how do you do that at low latency, right? And to detect something like it's a hallucination, you need subject matter expertise. You need expertise about how that particular business of Nike or Western Union operates to detect that there is a hallucination in the first place, that the policies have been violated. So once you have subject matter expertise at that level of business rules, then scaling becomes an issue. How do I scale this infrastructure of human in the loop at a point where it is not business specific? So these are some of the underlying problems, even though the paradigm is to say, well, we'll put human in the loop and it'll help guardrailing.
Thank you. One particular part I wanted to mention here, the seating arrangement is on purpose. There's a TCS there is a interactions here and Microsoft in the middle. And this is not necessarily kind of, okay, I'll come to that little later, that particular aspect, right? So there's too much of Microsoft in this afternoon, but we like that. Yes. Right. So, Manish, I mean, you are, I don't know how to, of course, I want you to introduce yourself a little bit, but I really can't just tell you whether an academic or an industry person. I'm very, very confused in terms of your paper productivity, also publication productivity, as well as your contributions to the applied research at Microsoft, right? So I'm sure you have a very different perspective looking at these part. But first, I would like your reflections after introducing yourself.
Thanks so much, Professor Vasu, and thanks for the invite here. My name is Manish Gupta. I have been working at Microsoft here, like 3 kilometers away, for the past 11.5 years. And I also have been working as an adjunct faculty here at IIIT for the past 11.5 years. So that's why Professor Vasu sort of said, I'm half academia, half industry. I also work as a visiting faculty in the middle at ISB. So that's that. Yeah, I think we are in the middle of LLMs, essentially day in, day out. That's all we do at Microsoft in Bing. At Microsoft, I work for Bing Specifically, I work in Bing auto completions. So you see the drop down that comes up when you try to search something. Right. I also work on Bing Sports. So, if you basically put up IND versus WI as a query, you might be looking for Indianapolis versus Wisconsin, right? And not necessarily India versus West Indies and so on, right? So, and I also work for search grounding, which is basically how do you find the right documents to basically give to this LLM guy to respond correctly, right? I think when LLMs came up, everyone, of course, wanted to use LLMs, and everyone is using LLMs. But then there's a whole bunch of problems around it, as folks were mentioning, right? You try to fill up one hole, the other hole comes up, and so on. So first thing, of course, is that it requires huge amount of compute power. So when I think about like auto-suggest as an application, right, where there are like hundreds of millions of users with billions of keystrokes every day, right? I'm talking about a crazy amount of compute that is required to serve them, right? And you can't like do all of this with LLMs, right? I mean, you can't be basically using LLMs to basically come up with a drop down for every user out there. That's just too expensive, right? Second, latency. There I have to actually compete. I mean, you mentioned about latency. I have to compete with users' typing speed. That's the latency requirements I need, right? And putting up an LLM there is complex, right? Hallucinations, but I'm not worried about just hallucinations. I'm actually worried about offensive hallucinations, right? So essentially, people are trying to autocomplete, and in that autocompletion, random things can come up from LLMs. So how do I control what this guy is speaking? Because this guy is actually speaking on Microsoft's behalf, right? When I'm putting it out, it's like Microsoft coming up with those recommendations, in the drop down, or whether we are doing related search, or people also ask. All of those are Microsoft recommendations as such, right? So how do we avoid those kinds of problems? And then bias, right? So essentially, these models sort of learn from what they have, what they've seen around, right? And the world that they've seen around is not unbiased. The internet world is biased. So in that senses, they return biased results. So then how do you ensure that all those are reasonable? But then, I mean, so of course, LLMs also suffer from things that traditional machine learning suffered. So I was at SRL Diagnostics, trying to sell them Azure. So there a guy basically asked me, why would I use a machine if it is not 100% correct? So basically, it has to be 100% correct. So of course, so LLMs are not always 100% correct. So therefore, when you use it in banking sector, finance sector, medical sector, LLMs, without human in the loop, I don't think one can dare use them, right? So in these critical sectors. So I'll stop here. Yeah.
Thank you. Sandeepan, would you like to?
So let me introduce first in a different context, because here we are in LTRC celebrating 25th years, and I am one of the one of the students from the very first batch who started working on Sakti with Professor Sangal and Professor Deepthi. And that time we were using reordering rules inside machine translation, which is considered to be the one of the complex problem, because translation and reordering, and the technology that we used is called mirror rule. So there my NLP journey started, and from there, like, I have finished my PhD, master's, and I joined into academia as a assistant professor in IIIT Guwahati. And then I came to this part of the world, worked few years in Xerox Research Lab, and then working with Microsoft. And to the panel's question that, or the myth versus the reality. So I was tainted when Bing Chat was being developed. So I'm not supposed to disclose anything. But people in general outside have a perception that when somebody is working on LLM or generative AI, they're all building models. But model building is something which is important, core, but not a large number of people working on that. And there is a tremendous amount of work that is happening outside the model building. For example, all the issues we are raising, like hallucination, grounding check, freshness check, especially like this year, we have like more than 80 countries have elections. Now, are we providing the fresh result when somebody asking LLM? So these are big challenges. Now, these essentially imposes two things. One is the ecosystem of the company, like big company versus small companies. So now Microsoft is a big company. We have established business. Now in that established business, we cannot disrupt anything. Now, so to maintain that disruption, like no disruption, we have to be very critical about evaluation. We do red teaming, blue teaming, purple teaming, all sorts of things happen. Sometimes we use LLM for that. Sometimes we do it like by human experts and others. Now, this is the amount of work we need to do in addition to developing just core of the language model to make technology into product. So this is the first like myth versus reality. And the second thing which I have observed, like people think that in Microsoft we have like thousands of GPUs, like I can just go and run something and I have like 800, 800, 300. No, that's not. We also need to fight for GPU budget and GPU budget at all level, like training GPU budget for deployment, as Manish was pointing, latency. That latency comes because we want to deploy something into data center. And if I say, oh, this is my latency and I need thousands of GPU to cater the entire world, nobody is going to give you. This is only the return on investment, how much accuracy in business you are getting. So that's impossible. So this latency budget and GPU training and top of LLM budget, look, can I run it on billions of queries that coming into Bing every day? I cannot, because that needs like LLM budget. Like, so these are all reality. And we always like believe that, oh, companies have that infrastructure, academia doesn't have, but company also suffering from that. But despite of that, we have very successful products like Bing Chat is out there, GitHub Copilot is there. So we don't need to be in that perception that everything is like a very, very good in industry.
Great. Sirish, you've been helping a lot of customers, directly, indirectly through your research efforts and so on. I would like to really describe something what you consider as the cornerstone of success cornerstone in your experience that actually highlights the importance of language processing, the importance of, say, LLM, Gen AI. This time, Gen AI, LLMs are included.
So I won't go into specifics for obvious proprietary reasons, but I think, of course, I mean, in exact material terms, if there's a deployment that you're really happy, but you've seen a massive change in the last 1 year in the openness and willingness to experiment, okay, and really try. I would say very crazy things, okay, to the extent that sometimes we have to almost pull back. So I'll give you, I was on lunch talking an example that somebody wanted to do like a persuasive bot in pharmacology. And I had to step in and say that this is too much. But definitely success that you're seeing in software development lifecycle, that was obvious for many, but clearly seeing some things coming up in creative work, those possibilities. And one of the things that by the nature of who we are, but it just seems to be making sense that this, so for me, ChatGPT was as much an HCI success as it was an AI success. So this augmentation of humans and how that is really playing out well and how that's going to bring up new research problems also, right? Because we just made a instruction follower. That's not the only form of alignment. There are other values along which one aligns. So that to me is turning out to be a very satisfying journey overall. Okay.
So I mean, there are a few, but I think the real value in of these deploying industrial NLP applications include accuracy, all the ETs, accuracy, scalability, adaptability, that are actually part of the architecture. But then you also have the bottlenecks in terms of the models that you need to use and so on. I mean, you are talking about your fighting for your milliseconds in order to deliver these things, right? In those, from those experiences, what are your views in terms of adopting, these models?
Right. I think so. The first thing when these models came out, right, publicly, the first thing is enabling new use cases, as you rightly mentioned, right? I mean, the ability to be able to talk to a bot and get the response in a few seconds compared to actually looking at 10 blue links. So that basically wows all users, basically. I mean, even for me, right? I mean, Bing Copilot is basically open as a tab on the side. And almost every day I do like brainstorming with my Copilot like 20 to 30 times, asking it things which I would have probably asked my senior or, some mentor out there, well, even text assistant for that matter, right? So basically, as just filing like a GSTR9 in the morning today, but, and there are some issues. And, when you get into those issues, if you filed your tax returns yourself, you would realize, oh, there's so much of pain out there, right? I mean, so asking those small little things and the ability of these new use cases, which we could not dream about or think about like 5 years back in time, is thanks to LLMs, right? So the other thing that happened inside the product groups inside Microsoft is that people started using LLMs to do all kinds of human annotation. So all kinds of annotation that typically would be done using humans, right? So essentially, we found that these annotations that we got done from LLMs were not just more consistent, they were accurate, they were timely. So especially getting annotations done. I work for Bing, and in Bing, we have to have so many annotations done, query document relevance, but there's so many relevance annotations that we get done. And across languages. So finding experts in Russian, in Chinese, and so on is complicated, but LLMs now basically try to help solve those problems. So I think those are some of the ways in which I think LLMs have been a blessing. Besides, of course, trying to help optimize business metrics like getting highest ROI, accuracy, or revenue, or whatever. In ads, of course, we have seen crazy, real revenue gains thanks to LLM deployments.
So Deepan, you want to use?
Yeah, just want to add one thing what Manish said, like achieving human parity is a controversial paper. Many conferences you go, they say like, it's not feasible. But within Microsoft, we have seen, especially for data generation, annotation, that it's achieving human parity. And when we put it in training and many other applications, that it's really worked well. So that's just want to add on that. But on the other side, when we were developing systems, like even 10 years back, we used to focus on the market. Like, okay, the technology will be delivered into this top 10 market, English, French, German, and so on. Now, why top 10 markets? Because we have business that's covering probably 99% of the business. But suddenly when this technology came, like multilingual bot and all those technology, our leadership says, no, you cannot develop technology for top 10 markets where we have business, because we have the technology. We can now develop it for any market and deploy globally. And that's a real change I found, that, okay, you are developing a classifier. Why restrict to few languages? Because you have technology, no longer market driven. It should be market, language, and task agnostic. And that's the real change I have seen in the past few years, that it's changed the spectrum of the deployment.
Right. Srinivas, would you like to?
Yeah, a couple of things. Dialogue systems are a multi-step decision-making processes, right? And our KPI, and I think the question was, what is the metric for a milestone? Is that fair enough? Yeah. So for us, the metric for milestone is when an end user interacts with the system and says, "Thank you very much. You solved the job for me. You solved the task for me." And to get to that stage, it's not a pure technology play. It is a multitude of aspects come into the picture, technology being one of them, whether it's LLM, rule-based, conventional machine learning. But designing an engaging system is beyond just LLM. It's how do you think about what is the demographics of the user base that interacts with that system. Take, for example, users who are transferring money in Western Union versus people who are making appointments with their, doctor, skin doctor, or a general physician. There are different kinds of considerations of that. And so measuring the KPI from the customer standpoint right? Not engineering, latency, accuracy are all good questions, but customer perceives a different goal, which is, did the system help me at all? Right? So the abandon rate helps you understand that, but their tone of voice when they're interacting with the system, right? So how much frustration they're feeling and how angry they get when they don't, their name doesn't get recognized and you're asking for the fourth time, right? How often they hit zero to get to the operator. These are all indications that you've not designed the system very well, right? So one last point about multiple languages. It is alluring to think about LLMs being multilingual. Yes, you can do it in German, you can do it in French, the same system. But reality is that the German population customer base interacts with the system very differently from an American data customer base. There are socio aspects of it that are not modeled by our LLMs or the dialogue management, right? How should the user be prompted in Japanese versus in German? Germans are very, very direct. Japanese are not, right? Very polite people, right? Whereas Americans are somewhere in between, I guess. So taking those aspects, if you take the customer effort as the gold standard, you have all of these other aspects that as technologists, we don't necessarily think about, which play into the success of the solution.
So in the one important missing element in adopting language technologies in general, but especially these Gen AI, LLM models in particular, the discussion of benchmarks come very often. So, I mean, there is models changing on one side, more and more domains are being brought in on the other side. And then the entire landscape is not stable, right? It's very, very evolving and things like that. So even to define success, we need to have certain exercise of benchmarking and then kind of, so there are, of course, several initiatives of this kind in the academic world, in the research world. But in practice, can you throw some light on how do you view this kind of the whole exercise of benchmarking and then kind of coming up with some kind of a metric for the success of a specific application versus the capability of the tool or the model? Surprise.
No, I think, I mean, like benchmarks are around. In fact, I'm so glad in the past 2 years or so, so many benchmarks have come up, starting from glue to, super glue and all the ones that we have today.
We're not talking about academic benchmark, but not for the research publishing papers, but actually deploying things.
That's true. So, but then, I mean, inside Bing, actually, we have our own Bing benchmarks. Now, those are leaderboards which basically teams internally fight on. So, for example, in ranking, we have a ranking benchmark. In AutoSuggest, we have our own benchmarks. So, ranking benchmark is actually very popular inside Bing. I mean, whenever a new model comes up, we of course try to benchmark on that stuff internally. But of course, there are also internal things that we try to benchmark. So there are internal ones, I mean. But having said so, right, I mean, even internally, we are looking more for quality rather than really optimizing for revenue as such. So you might think that, yes, internal benchmarks, do they really capture revenue? Well, they don't. I mean, we care about other, and including, we do, of course, do a whole bunch of A/B testing. So that's another way of benchmarking things to ensure that whenever we are coming up with new algorithms and new methods that are being deployed, we ensure that users are being cared for, and we have all the metrics in place on our scorecards, online scorecards, A/B testing scorecards, to care for user methods as much as for revenue as well.
Sure. Yeah.
I just want to add one point. So while the academic benchmark are good to get the first check, like, okay, it's doing good or bad, but to deploy the product, we don't want tomorrow morning a press release in New York Times that Microsoft is doing this because that's connected to dollar values. So I will share my experience when I was working with GPT Vision. So there we were giving some text and it needs to generate image and vice versa given an image. Now, I will take a RAI example. So like, excuse me for that. So there was a black person in an image and you can ask, spot me the person. So it will say like, or some you ask something. But that kind of data, when somebody is asking a question, spot me the gorilla on that same image, the model answers and the model fails. Now, how many possible combination of this image plus text where both of them are RAI compliant, they have no issues in terms of RAI, but together that is making it so complex. Now, that kind of data is very rare in like the benchmark that is available in market. So we had to curate our own data, lot of red teaming, like, okay, keep on doing, and like then red teaming goes into blue teaming and all those. So that for every task, like even for the complex areas, like, so we had another issue in image, like people, we were secured for captcha, that it should not break the captcha. But somebody said, this is my grandmother locket and it has some information, I want to decode it. And it decoded because of the story that they made. That model didn't identify this is a captcha, so it's a security threat, I should not do it. Now we had to create another benchmark for captcha where different captchas has to capture. So what I'm telling is that depending on the application, we had to create benchmark, and every time we see a error, we need to go beyond. And it's even more complex domain like security, compliance. So it's even harder. So we keep on doing that.
So see, this is, I mean, the nature of TCS, this becomes a very, I think, a slightly unique challenge for us, correct? So for example, if you have a product and a stable product, you can make internal benchmarks for you. But if you are getting a use case which is different constantly, you cannot make large scale benchmarks. And maybe the orgs that we work with, they upfront are not willing to, let the data cross boundaries. So you have no option but to do some sort of few shot evaluation and do iterative development. Okay. So I would almost go back to the research methodology that data-driven evaluation is only one form of evaluation of a model. I mean, argumentation can also be used as a research methodology, right? So what I mean by that is that many cases, even in few shots, if those few shots are chosen rightly, while it may not be acceptable for a NeurIPS or academic paper, you do get a sense of if this is going to work in the use case or not, which clears a POC, and then you do sort of a pilot and you do red teaming, blue teaming. Typically, that's how it progresses, at least in our case. Yeah.
Lastly, the question about the beyond LLMs, anything left in NLP that is being used in the industry in a very significant manner. So this is what.
Sorry for taking this question immediately. Yeah. Actually, Sriram spoke something. So even yeah, I mean, we're still developing DSLs. We're still developing grammars. The search space becomes too crazy if everything is NLP. I had one decent joinee who said that, but if the LLMs understand natural language and natural language is the most complex, why are you still designing grammar? But I'm not sure they approximate natural language. I mean, so many things are still up for debate. So I think these are not done. And plus, I saw this discussion on linguistic theory. I don't know whether LLMs have a linguistic theory, mechanistic interpretability, what is really going on. I mean, things have just happened very fast, but so many open questions just remain, right?
Just to add to that, right? I mean, I was going to say the same thing. Sriram talked about how they have been trying to use still older software engineering kind of theory in combination with LLMs, right? So, I mean, I think tool usage is something that is very popular with LLMs, and for a reason, because LLMs are not good tools by themselves. So essentially, in fact, Monica is here. So we basically just recently did this tutorial in knowledge reasoning conference where we basically, more or less pass the message that LLMs are great, but they may not be great reasoners. So they can actually come up with really good outputs, and correct outputs don't necessarily mean correct chain of thought or correct reasoning in that sense, right? So I think, and therefore a lot of people are actually banking on external logic-based systems or software engineering systems, so as to have LLMs define inputs for them and parse the outputs from those systems, but then, hey, depend on them for correctness purpose, right? So that's that. The second thing, of course, is that LLMs can't be like retrained every day. So essentially, therefore, therefore, we have to supplement them with fresh information. So essentially, when we brought up the Bing Copilot, it was not like just taking OpenAI ChatGPT and productionizing it. We basically make use of the huge amount of fresh and recent information that we have at Bing, so as to be able to pass it as extra context. Everyone knows that as retrieval augmented generation now, right? So LLMs by themselves, are limited. Therefore, you have to basically pass on that information from some external store to enable them to do that. And there is a lot of NLP left to do that, do there, right? So essentially, how to build those stores correctly. How do you take the latest that is happening in sport matches and somehow gather all that information so as to surface it nicely as extra context to LLMs. There's a lot of NLP which is still involved there.
Yeah, for me, I'll answer this from a different angle. So far, I'm seeing LLM as a cost reduction tool rather than revenue generation tool, because it's not finding any business where it can generate revenue. So the addressable market versus it's actually operate on the addressed market. It's not creating an addressable market. Now, so we need to find NLP applications in that space, like where LLM can solve something that can bring revenue. And of course, like technically, as Manish was saying, RAG, and then following that, like knowledge graph, memory, and all these things people are trying to incorporate into LLM. Because if I want to deploy something in IIIT versus another institute, the terminology, the information, that varies significantly. Now, if we know that attention is a very successful technique, but what it is attending, if it is a general LLM, it's attending to every knowledge that is there. But if I specify that, okay, there is a knowledge which is specific to LTRC, IIIT, then that attention will be much more useful. Now, how this knowledge graph can be built, how that can be embedded into LLM, these are some space, even memorizing, like all those. So this is all, but in a nutshell, like we haven't found any problem in language processing which LLM cannot solve reasonably in its current state, and we haven't found any problem which can generate revenue because it's mostly operating on the space. Like I can summarize things. If somebody pay me some, say that, okay, to use LLM you have to pay, I'll say I'll do my summarization on my own.
Yeah. When you were asking about benchmarks, I don't know if the academic community deliberately called it super glue, but we are certainly stuck in that. But yeah, so going back to your question about evaluation and the next steps, so to speak. Of course, we all are beating up on LLMs. Right? And many of us in the audience may feel like, okay, LLM is the villain there, right? So we have to beat them up. But there's some power to these tools. And we need to figure out how to leverage that power, right? The classical AI systems had their brittleness. They had interpretability in the mind of the designer. So if an expert system were to fail, you would go and ask the designer of the expert system, what did it do, or why did you suggest it as malaria? Right? And there is a reasoning step behind it, and you can go and ask them. Today, we are trying to figure out if LLMs can do that kind of reasoning. And if it is, what is the error tolerance around it? So I think the future would be mostly around trying to figure out whether there is a way to quantify the error, there is a way to assure the user base. And simultaneously, I think the user base is going to become more tolerant. You know, in the early days of speech recognition, people would quibble about, oh, you got that word wrong, you got that other word wrong. Not that ASR has completely solved the speech recognition problem today, but the user base is a bit more tolerant about errors. Now, the question becomes, will the user base in 5-10 years be tolerant about hallucinations, or figure out ways in which we can mitigate hallucination on one end, but also the user base saying, okay, I can understand, I won't trust this 100%. Like, so maybe we'll figure out a middle ground where we can have a happy marriage to go about.
Great. Fantastic. At this point in time, I'm aware that we don't have the luxury of too much of time, but I would like to open up the floor for questions from the audience. So. You can take the mic from here.
Yeah, when it comes to benchmarking, what we do is, with respect to each business use case, we prepare the ground truth data set. Like suppose say, what is the prompt and what is the expected answer? We manually prepare it and we will evaluate across the different large language models. Suppose say if we take 20 prompts, 20 answers, and we verify with all the LLMs and see which LLM is doing better. So it is very specific to the business use case, basically, not on the standard data sets, what we do usually. When it comes to the accuracy and latency, right? So what we are trying to do is we will collect the feedback and we will collect the prompt and the correct answers. Going forward, I come across Frugal GPT research paper where we see that some of the prompts are repetitive in nature. So what we do, as we have the prompt and the correct answers, so we do the sentence similarity, it almost matches at the high, like 0.98 or 99. Then we need not send the prompt to the LLM. So directly we'll answer it because we have the answer already. And sometimes what we do is we collect the prompt and the answers. We'll try to do the fine tuning. Then we'll see the sentence similarity is not matches. We'll go for the fine tuning. Still the fine tuning is also not works. Then we'll send to the LLM. So that's how we plan our roadmap, basically. Yeah, that's what I wanted.
So it's more of a comment rather than a question. So thank you. So if there are no more questions, then maybe we will close the session. And thank you so much for this enriching discussions, and really, really thankful for you making time for this event.
Thank you so much for the engaging session. I would like to call Dr. Swaran Lata to present the panelists with a token of appreciation.